So sample space is another way of showing all the possible outcomes of an event without having to list them, okay? Sample spaces could be, say you have a 2 die, a 6-sided die. This right here, this particular sample space, the one on the left, represents all of the possible outcomes you can get by rolling these 2 dies. And then the one on the right is another representation, it's another sample space that represents the particular outcomes when you just using dots instead of the actual numbers themselves. So it's kind of like what Venn diagrams are, or like a table that kind of lays out what your different outcomes are. This is just another visual representation. So we're going to use these sample spaces to answer these set of questions here. So using the diagram, either diagram, it really doesn't matter. We're going to find the probability of obtaining a score of 6, rolling a double, and scoring less than a 6, okay? And by this, like scoring a 6 meaning the sum on the die is a 6. So let me clarify that. When you roll the 2 die, the sum is a 6, okay? So you have to find the probability of obtaining a score of 6. That means you're rolling these 2 die and you're trying to get a sum of 6, okay? That would be here. When you roll and one die shows a 5, the other die shows a 1, that's the sum of 6. We're here. We're here. All of these show a sum of 6. Are there any other places where there's a sum of 6? No. So what is the probability of obtaining a score of 6? 5 out of 36. Then the next one says, find the probability of the same number. A double. Not a double 6 or a double 4, but rolling a double. Okay? How many times does that happen? 6 times. That's here. All the doubles. So that will be 6 out of 36, which reduces down to be 1/6. And then the last one was find the probability of what? A score less than 6. A score less than 6. Well, if the pink represents all the scores that were 6 exactly, then the ones that are less than 6 will all be all of these, would it not? And how many was that? It was 10, which reduces down to be what? 5/18. Simple as that. So you can use sample spaces to help you, it's just another visual, okay? And by writing on that, you know, what if, you know, I'm going to ask you a follow-up question such as, what's the probability of rolling a score of 6 or a double? What's the probability of rolling a score of 6 or a double? Think about it. What'd you guys get? 5/18. 5/18 is very good. Hopefully you did not count the double 3 twice, okay? Even though there are 6 out of 36 and then 5 out of 36 for the 2 respectively, there is, you know, you're counting double 3s twice. So you can also use, you know, for an example like that. Independent events, also known as product rule, okay? Independent events are when the outcome of one event has no influence, no effect on the outcome of the next event, okay? That's what makes events independent. You'll know when 2 events are independent when the probability of their intersection equals the probability of the 2 events multiplied together. This is known as product rule for independent events, multiplication rule. And we're going to look at an example of that. So look at this example that we have. It says one bag contains 3 red and 2 white balls. Another bag contains 1 red and 4 white balls. Right now, we already know that when a ball is selected at random, these 2 are independent events. Just because we draw 1 ball out of the bag that has 3 red and 2 white, it has no effect on us drawing a ball from the other bag that has 1 red and 4 white. So these are independent events right here. Knowing that, we can use the rule, the product rule for reaching into bag one and pulling out a red ball? A little louder because of the air. 3 out of 5. Okay? We reach into the second bag and we pull out a red ball. What's the probability of pulling out a red ball? 1 out of 5. So what are we going to do to these two probabilities? We're going to multiply them. Okay? And again, these are independent events. So what's the probability of both balls being red? That is going to be 3 out of 25. Okay? What about the balls are different colors? That means we reach into bag one, we can pull out a red ball, or reach into bag two and pull out a white ball. Or vice versa. Reach into bag one, pull out a white, bag two, pull out a red. How do we figure out those probabilities? So bag one is red, bag two is white, and then again, bag one is white, bag two is red. Okay, what do you think we're going to have to do to those probabilities again? So like multiply this times this?
Yeah.
Well, we do need to multiply these two probabilities together, but once we get those, we're actually going to add them, okay? Because they're basically two different outcomes that can happen. So two different probabilities, but we're going to add them together at the end, okay? So what is the probability of reaching into bag one and pulling out a red ball? And then we're going to multiply that by the probability of reaching into bag two and pulling out a white ball. 4 out of 5. Because that's just one outcome. But we could reach into bag one and pull out a white ball instead. What's the probability of pulling out a white ball in bag one? Which means that we have to reach into bag two and pull out a red ball, which is, say again. So then we multiply these, we do the multiplication and then we add them together. So what's 3/5 times 4/5? 12 25ths? What's 2/5 times 1/5? And when we add them together, we're going to get, that's going to be our answer for B. That's the probability of reaching in and pulling out different colors. Questions? Okay, what about the last one? What's the probability of that we draw at least one white ball? One white ball, at least one white ball. Thoughts on how we can do that? Figure out that probability. Okay. So pulling a white ball from each bag. Okay. It does say at least one. So we could get one, but that means we could get a white one from bag one or a white one from bag two. But then that also means we can get two white balls. So don't we already kind of know the probability of getting one white ball already? We just did it in part B. The one thing that we don't know is the probability of getting two white balls, correct? So we can find the probability of finding two white balls and then add those together. That's one way. It's another way. You are on the right track. Yes, okay? It says something about red balls, right? And then something about subtraction. I feel like you were going towards what when you said subtraction?
I don't know.
Okay. Well, someone build off of what Reagan said. She's on the right track. It's another way. Yeah, essentially, that's what she was trying to say, right? Okay. Well, think about it. If you draw at least one white ball, right? That's either red, white, red, or white. We can find all three of those probabilities and add them together. But already figure out when the probability of both balls being red? Well, the complement of that would be at least one of them would have to be white, correct? So the complement of both of them being red is exactly what C's asking. Because if both of them are not red, that means at least one of them has to be white. So we can just do 1 minus our answer to part A to find the probability that at least one ball is white. We would get the same answer if we did it the other way, you know, red, white, white, red, white, white. And what is that? $22 out of 25. And we would still get the same probability. But at least this way, we're already using an answer that we have instead of finding another probability and then adding the final probability. So questions on independent events?